Sorry. Previous video was about RL. Yeah, you asked me RC, right? Let me explain. RC, draw that RC diagram. For RC means DC voltage will be there. For DC voltage will be there means constant voltage. So at T is equal to 0 minus as switch is closed, current will be 0. At T is equal to 0 as switch is closed, current will be 0. At T is equal to 0 plus, here at capacitor doesn't accept sudden change in voltage, because suddenly if you on the switch, sudden change in voltage will take place. Capacitor doesn't accept that sudden change. So complete current will be there in R only, resistor. So I is equal to V by R. Now apply KVL. You will get VR as IR, VC is 1 by C integral IDT, and C will come here. VC is equal to IRC plus the integral 0 to T IDT. Differentiate it, you will get I. Again RC differentiated, and dV by dt is 0, because DC voltage means this is constant voltage. That's why dV by dt is 0. Okay. Now you will get di by dt plus I by RC is equal to 0. This is looking like an homogeneous equation, right? Because 0, no constant, dx by dt plus px is equal to 0. So for this homogeneous equation, the transition state is x is equal to e power constant into e power minus pt. I of t is equal to k into e power minus pt. I of t is k into e power I of t is equal to k into e power minus t by RC, because here P is 1 by RC, right? 1 by RC is P. So P is 1 by RC, so minus T by, minus T by RC. Now this K is a constant. So at T is equal to 0, I is equal to V by R, right? We need to find this K value. So V by R is equal to K into e power 0. K is equal to V by R. I of t is equals to K value, substitute V by R into e power minus T by RC. So you got current. And here the tau is RC. Tau is equals to RC. And here tau is measured. Time constant is measured in terms of second. At t is 0, I of 0 is V by R into e power minus 0. E power 0 is 1. I of 0 is V by R. At t is equal to 1 tau, you find. At t is equal to 2 tau, you find. At t is equal to 3 tau, we need to find. 4 tau, we need to find. 5 tau, we need to find. 10 tau also you find. And from t is equal to 0, you got V by R. Slowly it is decreasing, and at I of 10 tau it is 0. So it will decrease. Plot this graph. So first step we found current. After finding current, we found all values, like at t is equal to 0, t is equal to 1 tau. For all time instance we have found current and plotted a graph. Now we need to find VC. Voltage across capacitor is 1 by C integral I dt. I is V by R into e power minus T by RC, right? Find integration. After integration you will get a constant, arbitrary constant. So to find this constant, at t is equal to 0, V voltage is 0 is equals to minus V into 1 plus m is equal to V. Substitute. So VC of t will get V into 1 minus e power minus T by tau. Now VC we found. For this VC, we need to do at t is equal to 0. VC of 0 is 0 only. At t is equal to 0, VC is 0. At t is equal to infinite, VC is infinite. Also, first step, find current. And for current, we need to find at t is equal to 0, t is equal to 1 tau, t is equal to 2 tau, and you find all for time values and plot a graph. Second step is VC. Find voltage across capacitor. Find the formula. Now at t is equal to 0, you find. T is equal to 0, you find. At t is equals to infinite, you find. That's it. Now for VR, voltage across resistor, you find as R into I, right? I means we know, which is V by R into e power minus T by RC, right? Find VR, voltage across resistor. At t is equal to 0, you find resistor. At t is equal to infinite, find voltage across resistor. T is equal to 0, it is V. T is equal to infinite, it is 0. Now you plot a graph. Now VR, see, for VR, at t is equal to 0 is V. T is equal to infinite is 0. So it is decreasing. For VC, at t is equal to 0 is 0. T is equal to infinite is V. T is equal to 0 is 0. T is equal to infinite is V. It is increasing.